Kipley. Good afternoon, everyone, or good morning, according to what time zone you may be on. Thanks for joining us today. I'm Brandon Ellis with Elitech. We're based out of Knoxville, Tennessee. I'll tell you a little bit about that. Let me jump straight into our agenda for today. Essentially, I'm going to go through just a quick introduction of us, our company, and what we do. We'll keep that short and sweet, but certainly we want you all to check us out online or through social media. We'll review some traditional IoT requirements. Now, the reason I want to do this is our IOTA Enterprise Gateway Appliance that Kipley spoke about, which is a device-wise based product for us. Not everyone on this call is probably familiar with that device, so I want to quickly walk through how it came to be and what the advantages are of that, because those advantages will tie us directly to this use case and why it was the perfect solution for that use. And then we'll, of course, have conclusions at the end and wrap up. Now, this is not going to be just PowerPoint. I'll flip over to a live demo, and so you can kind of see what we've got going here. But then we'll be watching those questions coming in on the chat window. If you have any questions during the presentation, please post them on the chat window, and we'll get to each one of them. So with that, let's begin. So first of all, Elitech. Elitech was created or founded in 2009. We're based out of Knoxville, Tennessee, so we're on the Eastern Coast, Eastern time zone. Our focus is industrial IoT and Industry 4.0, smart manufacturing. We've been doing this for quite a number of years. We actually started as an integration company, and we still have an integration arm. It's very important to us because it keeps us tied to the end users in our industry. It helps us to develop our products better. But we focus on MES data and on systems and things of that nature. And then with our integration group, they're still involved with CNC and industrial automation systems and robotics. But still integrating those systems onto plant-wide systems onto an MES system. We developed our Data Commander in 2014, and that was our first MES gateway appliance or enterprise gateway appliance. And of course, we've been working with Telit since then, actually before they were Telit. So quite a long time, as Kipley had pointed out. Our mission is pretty simple. We don't want to just build products and solutions just to have sales. We want to empower our clients. We kind of tout ourselves as being the iPhones of industrial IoT. And what we mean is we want to empower those either through the integrators, through the developers, empower them to empower their customers so that their customers can act more in a partner means versus having to rely 100% on the support requirements. They're going back to the developers and the integrators. But we want that to be our driving force, is to make sure that the experience in using our products, be it from the integrator level or the end user level, is a good experience. So that said, let's talk a little bit about the traditional manufacturing execution system. So the execution system consists of a couple of typical items, and I'm sure probably everyone on this webinar is familiar with these, but let's roll through them real quickly. The data server, of course, the database server, is where the work tables and stored procedures would be. This is where we can handle a lot of work, anything from workflow management or general reports and things of that nature. Then on the other side, on this enterprise side, we also have all of our, is where we would typically host all of our web-based reports and things of that nature. And then, of course, then you have your plant level or plant floor where your machines are. And these machines many are using non-PC based platforms and have for many, many years. So a lot of legacy equipment there with PLCs, robots, CNCs, and then again, industrial PCs, if applicable. And then they're all tied together, usually, traditionally, with a PC-based software. We refer to that as middleware. And they're all tied together with at least one common network. So hopefully this sounds familiar. If it doesn't, then this is what that is kind of going to be. So why is this a big deal? Well, initially, the question is who owns what. So the database server, the IT side, that's usually owned by IT. The database administrators, the DBAs, usually handle the visualization and the reporting. Usually, manufacturing engineer, production engineering kind of own or are expected to own the machines on the plant floor, and then the network admins own the network. But the question is who owns this middleware PC? It's half IT, half engineering from a software and a hardware standpoint. And so it's always presented a philosophical issue. And so it's from that we, back in 2014, saw this, and we developed our Data Commander. It's a hardware-based appliance with the network separation, the integrated hardware-based firewall. It made sure that IT was happy that nothing on the floor could hurt their systems up top, and it made sure that that engineering wasn't affected by something going on at the other side, and then it could be owned by either IT or engineering because it's not half and half. So that was our Data Commander. So how do we keep with our mission to keep simplifying and making things better? Well, the issue we saw was you still have to get a lot of people together. You've got to get the database, the IT folks on the database side, the database admins together. You've got to get the engineers together and so on and so forth, and the network admin. There's also a lot of latency issues. So what we essentially did was we took the database server, we took the process control portion and the visualization, and we put them all together, and we created our IOTA edge-based data, which is a data server appliance. And so IOTA stands for Industrial Internet of Things Appliance. And so it's an acronym, but that's essentially what it does. And it allows us to pull data down to this edge-based appliance. We still have all of the hardware-based firewalls and things of that nature, but this means that we can do what we call ride-through. It also knocks out latency issues. This is from heavily populated internal networks, LANs, but also ISP-based issues going from plant to plant, or if the database main data center is remote or cloud-based. But we still have device-wise inside, so we still can put hooks into the external, either cloud-based or hosted database servers, and still allow them to get to the reporting and all the things that they need to do. But we're connecting the plant floor to the IT side, but we're doing it through two separate systems. You can see our enterprise LAN at the top and our plant floor LAN at the bottom. We have that separation. So that said, just reviewing quickly the advantages of an edge-based server is essentially the data can be placed at the point of operation versus a remote or cloud-based data center. The primary advantages of that, of course, are reduced delays from the network traffic and instability and those kind of things, but it also decentralizes the data, so we can actually do our mashups and everything down at the edge-based. And then thirdly, single ownership. So many ask, well, why couldn't we just stick a PC down there? Well, we can, you can, but a PC doesn't always hold up in an industrial environment very well. Mean time between failures on a standard desktop style PC is 6 to 8 months. The second thing is it's a Windows-based environment, and if you're an IT security person, that probably brings up all kinds of concerns, because now you have to own that part of it from a security standpoint to make sure that it's still secure. Cybersecurity, of course, is a very, very big deal today and growing every day. And so an appliance-based, hardware-based system on the line is much less risk, a higher risk than a PC-based solution. It's also industrially hardened. And then thirdly, we put this photo in because I'm always asked, how big is this device? You can see a standard ink pen beside it, fountain pen. It's about the size of an Xbox if you're a gamer. So that said, again, the major advantages of the IT ride-through and just the zero latency because the data is local. It's fast and repeatable, and it gives us the ability to control the upload cycles as well. We showed where we could still get hooks into the upstairs side, so we can utilize store and forward and things of that nature. So historical data that needs to last longer than a few months, we can still get upstairs or to the cloud or wherever it needs to be. And then, of course, we talked about the security. So now let's get to the use case. So I appreciate you going through all that with me. Hopefully you have a decent understanding of how and why we developed all this in an appliance-based and edge-based platform. So for this specific customer, and this is use case number 268, so there's thousands of use cases that could be done, and we picked this one. So in this case, we had a standard, this is just a conveyor-based assembly line. And so at each line, they're doing processes, a certain process. But the pallets, so we've got an initial pallet staging, we've got a station 1, station 2, and station 3. Well, these stations carry certain processes that they do. The pallet could be holding any part. And so as it's passing through the station, that station has a specific thing that they do to that part, but it may not be the exact same part of the one before, so they can vary. So what they have to do is they have to communicate to the individual associate at that position what items, what order of operations, things of that nature that need to be followed for that specific part that's on that specific pallet. And so their traditional way of doing that was essentially they had a scanner at the first station. And all this station was being used for was basically creating this staging operation. And so they would scan a barcode, and a printer there would print out on an 8.5 by 11 sheet of paper this standard of work. Now, granted, this factory was not ELITech Incorporated, but we've had to change some things to protect the innocent and maintain our non-disclosures. But nevertheless, this would print out this standard of work. And then this, the operator at the first pallet staging, their job was to place that on the pallet, and then it would follow the pallet down the line. Now, these are pieces of paper in a factory environment. It gets hot in the summer because we're in the South, and so it's common to bring out fans. It's not necessarily air conditioned, things of that nature. And so you can imagine what happens with the paper. And from a quality standpoint, if the paper that's on station 1 currently is blown off along with station 2, and they get transposed and the wrong one gets put back on the wrong pallet, then that can be lead to all kinds of issues. And so long and short, the paper just wasn't getting it done. We needed to get rid of this, and then also it was just causing a lot of issues as far as it was very manual. So they wanted to eliminate the routers for a couple of reasons. The routers were they were printed at the front of the line. It was a PDF populated by custom applications. They were gathering data. I did mention that, gathering data from a remote AS400 database system, and remote meaning in a whole nother state. So they had to deal with that. The primary reasons, the lost or mishandled documents. It was very manually intensive because they had someone dedicated to just scanning and getting these things there, keeping paper in the printer and things of that nature. And then they also had a plant-wide green initiative that they wanted to promote, and just killing the paper, getting rid of the paper, reducing the paper was part of that. And so there were quite a few very good reasons for doing this. So how did we solve this? Well, enter the IOTA. Essentially, we brought in the IOTA system. We installed it down on the edge base at the line side. RFIDs were installed at each station. You notice that the scanner's missing now. So that pallet staging area that was there before is now used as can now be used as just a standard operational station. So they can begin their work there. And essentially, it's like you would think. We added these individual monitors. You notice they're in portrait mode. And we'll talk about how we did that. And so now, as the pallet moves down the line and the RFID is actuated, then we are notified of that through the control system, the PLC control system. Using deviceWISE, we're grabbing that information out of the PLC. We're going back to our internal database and querying that information, and then we populate those things. So essentially, quite a few immediate benefits came from this. The elimination of downtime events from slow server responses. That was one of their number one downtime causes, was because even when they were scanning with the hand scanner, they would scan the flip chart. You had to get the information from the other database in the other state, and if the ISP went down for the day, or if they had just network issues or something like that, it was a variable as far as how that would affect production. It certainly decreased the production time because we were consistent on those responses. Troubleshooting went way down because now they could troubleshoot everything right there line side. They had everything they needed to line side. They didn't have to get people in other states involved. It was a familiar platform because they were an existing Data Commander user already. So our Workbench front end and things like that were familiar. And then Production Engineer empowered them. And remember our mission statement, to empower the customers. So they were empowered to get the data they needed in a way that they needed it. And so essentially the database, we pull the database to our internal database, and then that information then is moved over to this document. But the document is an electronic document, and that's one of the main differences. So let's hop over to a live demo, or actually to the finished product. So let me just pull it up. So here you go. This is an example, and we've got this just simulating. I don't have a full document, so we've got a couple of descriptions. I don't have the whole thing done. And again, this is showing for ELITech. But you can see that as the palette or the RFID would pass in front of the sensor, then that would trigger new data, and we populate that on the screen for the worker. And this is popping between two ECN numbers that's bringing that information up. And so you also see that this isn't a standard browser environment. And so in this browser environment, since it's HTML, this can be displayed on any device that's on the same LAN or the same network. But thirdly, because we can create it in a HTML-based environment, it can be viewed in both landscape or portrait mode. Since this was an 8.5 by 11 standard, that's what they were used to. That's what we were able to do when I commented that we had portrait mode going on. So let's look at quickly how that's done. So to do that, we use our IOTA Manager software. This is ELITech software, but this is how we would build that. And so just for fun, I'll drop a text field here to show you how it works. And essentially, hang on, I'm going to have to end this PowerPoint. I apologize. So I can get to the screen sets that we need here. So we drop a text field. There we go. It's popping up on my other screen. I apologize. So we have a text field. So this will be text number 1. We can give it a color for the, and again, these are popping on the other screens. I'll drag them over. So we can make it a white text. We can put that down here as saying, hooray for IOTA. And we submit that. And so now we can size that. And if I simply save that to the node, we see down here that it's actually generating a site, connecting to the node, and is uploading it. It will let us know as soon as it's done, which should be momentarily. There we go. So the node is uploaded. So now we'll go back and refresh. And there you go. So just like that, with this drag and drop interface, we are able to create our own dashboards. And so why is this significant? Well, there's a lot of stuff going on in the background. If you've ever done any type of these dashboard developments, there's a lot of stuff going on. But we're connecting a database to a visualized product here, and we're doing all that in a standalone system. And why that's possible is because the IOTA houses the, let me bring this back up, of course. It houses the database, it houses the web server, it houses device-wise that talks to everything, and brings it all together in one environment. And so by doing that, we can then get control of all those aspects and use a singular software package, in this case, our IOTA Dashboard Builder, to build dashboards. So that said, let me jump back to the presentation. We're going to get to this in a second, so let me just take a pause. Kippley, as far as the use case, do you have any questions that we need to, anybody have any questions at this point?
It doesn't look like it, not so far, so continue.
Okay, we'll continue on. So that was our use case number one. So in talking with Kipley and the folks at Telit, we've talked a bit more about webinars and future webinars that may be beneficial to you all. So we thought it would be fun to do this. First of all, free demo at elitech.com. I'm going to refer to that again. You can see it on your screen there. And we'll be monitoring this even beyond, certainly beyond this webinar. So if you think about it, if you're watching it and it's not live, then it's no problem. Please send your votes. But a couple of things that are built in also to our IOTA product is, and then again powered by deviceWISE underneath, but is our workflow setup. So basically this allows the user to define a specific workflow so they can build their whole environment, they can name each process, and then by simply point and click, they can connect the arrows to define what what path a serialized part should follow. We refer to this as skip check or defect flow-out prevention. This is part of Zero Defects Initiative if you're on the production side or quality side. And it basically says that whatever part it is, whatever part number, in this case red part, must pass through input 1, wash bin 1, scrub machine 1, so on and so forth in that order. And if it doesn't, then it can send the information back to the controlling device, the PLC or robot controller or CNC controller on the paint machine, for example, or the scrub machine. It'll send that information back at the onset of any cycle request to say, yes, this part has passed everything upstream, or no, it hasn't, and it causes the operator to have to throw out and force out the part. So we refer to that as skip check. So if you'd love to see that as a webinar in the future, vote skip check, send that to freedemo@elitech.com. But there's two more options. So the second one is our dashboards builder. Now this is part of what we just talked about, but now this has to do with line-side dashboards and things of that nature. If you'd like to see that, vote dashboards, same email address, freedemo@elitech.com. And then thirdly, just the local data storage. You heard me talk about that as far as how we can store that locally. We've got the ride-through capability. We can do store and forward to get it upstairs. That's line-side data if you were to vote for that. So these are three things we thought would be interesting. And if this is something you would love to see, I'd like to learn more about that. We would love you to send that in an email, freedemo@elitech.com, and we will, as we're seeing interest, we'll put something together, work with the guys at Telit, and we'll do another one in 2020. So that said, actually, I want to show you one thing real quick. I'll jump back to our dashboard that's running, and I want to show you one other version of this. And this is the dashboard tool that we just talked about, and is an example of what that can look like. Again, building these dashboards with these changing devices. It's great for real-time monitoring on machines, for OEE monitoring and things of that nature, and extremely easy to do. So that said, I will turn it back over to Kipley. Just remember, call us if you want a free web demonstration. That same email will work, freedemo@elitech.com. Our website is www.elitech.com, and our phone number is posted right here. Give us a call. We'll set up a free web demonstration. We'll find out more about your specific application and see if we can really dial in on it. Kipley?
Very good. Thank you so much, Brandon. We really appreciate you joining our Telit Live event today to discuss your product and your customer use case. At this time, if you have any questions, go ahead and post them in the chat. We'll wait for a couple of minutes to see if anyone has any questions. But it looks like right now we don't have any. But if you have any questions, like I said, please ask them now. And then again, I just want to reiterate what Brandon was saying. If you're interested in a free demo of the product, again, he's put the information on the screen as well as his phone number. And then also, if you have any questions, you can also reach out to me and I can put you in contact with Brandon from Elitech as well. Well, it doesn't look like we have any questions. Oh, okay. Actually, we do have one. A couple of them are coming through right now. So, Brandon, what is the operating system in the IOTA?
Good question. The operating system of the IOTA is a Linux-based kernel. Now we modify that kernel to make it a bit proprietary. Proprietary. We do that on purpose. We do that from a cybersecurity standpoint. This product is standardized upon by a lot of users in the both automotive and also medical device manufacturing worlds. And so cybersecurity and HIPAA and FDA requirements are certainly a big deal. So we want to make sure that we're as secure as possible. So we make some modifications so that it's not run-of-the-mill. We remove a lot of pieces and parts. If you have more questions about that or you want to have deeper discussions about the security and what we do, but it is a Linux-based kernel at its very deepest part.
Very good.
Question.
And we have another question here. Does this hardware include a device-wise license?
Yes. All the hardware does include device-wise, and it does come with a full-on device pack. So as far as all of your major PLCs, CNC machines, things of that nature, certainly we support that. And then there's an annual support that's included for the first year, and then follow-up support after that.
Very good. And it looks like we have another question here. Is it Ubuntu?
It is not Ubuntu. Ubuntu is kind of large, so it's not a great operating system choice, I don't believe, and certainly people can argue with me, for an embedded low power environment. So granted, we're not an ARM processor. We're a step up from that, x86 and 1 gigahertz and things of that nature. So we've got plenty of power, but we want to reserve all that power for the applications and not for any kind of extra overhead.
Very good. And then we have another question here. Is data redundancy built into the IOTA?
Data redundancy. I'm not exactly sure I understand that question. So if you want to hit a follow-up on that, do that while I'm trying to pretend like I understand it. Data redundancy, as far as backing up the databases, what we would typically suggest there is that, again, because we still have the device-wise, we get hooks in upstairs to the or in the cloud to the data center or the main database server, and we utilize that along with store and forward capabilities to make sure that any specific data is backed up. The data, of course, certainly does make it through, does go through ride-throughs and power cycles and things of that nature, and it is all solid state, so nothing is spinning media and things of that nature. But as far as if it's critical, we always work with our customers to make sure that they can, every time they update the local database, that they also synchronize with an upstairs database. Similar to the use case where we were pulling information down from the main database, it was stored primarily in the AS400 system, and then if there was a change to the AS400, it would notify us, and we would then do a batch select and pull all that down to the line-side server.
Okay, and we have another question here. How do you make the connection with the device-wise variables?
That's a good question, too. I don't know what our timeline is, Kipley, how much I can show, so if I go too long, you let me know, all
No,
right?
I will. Go ahead.
So essentially, we have what we call our manager here. So this is, we can basically add a variety. I've got a variety in here of databases, or I'm sorry, of tags, tag names or field names that we can add. And so from those, then, we can reference those in device-wise. So built into the IOTA is a stored procedure. Again, remember, the database is inside of the IOTA, and so from our workbench, you can access that stored procedure. And so in the stored procedure, then, all we simply have to do is do a transaction and reference whatever name that we've created here and assigned as the value. I'll open, you can see it here anyway, but I'll open this up. So we see here we're using the value, and here are all those tag names that were created. So in this case, I've got data1_0, which hopefully you can come up with a lot better, more creative names than I did for this demonstration. But that's essentially what we would be in the store procedure call. We would be doing basically updating the value through device-wise. It would be writing the value into this data1_0 argument in the store procedure. So it's pretty easy to do.
Very good. And then it looks like we have one more question here. What is the database manager in this hardware?
The database manager, okay, so in our hardware, we opted to go with a DB2 database. We did that because we couldn't use Microsoft SQL because it's 64-bit. We're an embedded processor, and we're 32-bit. We don't need 64-bit, quite honestly, in embedded. And DB2 benchmarked as fast or faster response times than Microsoft SQL, and absolutely blew the socks off MySQL and all the other standard, I guess, more standard databases that you might choose in this environment. But that said, DB2, we divided it in two. So we have schemas that are private. They are specifically for our IOTA manager. And then we have a section that we break out for the end user or for the integrator. And they can access that using credentials. We basically provide them with the primary owner credentials. And they can use dbeaver or any amount or they can do command line for that matter, to access the database. It's totally open and available. And of course, we are assuming that the individuals use that with care, and they are qualified to as a database admin or an accidental database admin as I am, to be able to make those changes and utilize that. But it is DB2.
Alrighty, and then we have another question here. How many networked stations/equipment can the IOTA connect to simultaneously?
That's all based upon licenses, and we base that based upon device-wise licenses, and device-wise licenses come in connections. We jump off at 10, and then you can add those in increments of 5, 10, 20, 60, 80, something like that. And then it comes down to how much data you're moving and how often. As is the case with anything, any engine, you can finally get it to the point that it won't work. We usually, just as a rule of thumb, we'll say 100 connections per unit is a good maximum. But again, it's according to how much data you're moving and how often. And also how much you're doing in terms of dashboards and things of that nature. So all those things need to be considered. It's not going to blow up. It's just that you may start seeing some latency just because the CPU is being overworked. But typically, we say up to 100 connections is fine.
Alrighty, very good. And it looks like that wraps up all the questions that we've had so far. So if anybody has any additional questions, again, you can see the email from Brandon is freedemo@elitech.com, as well as his phone number. So with that, Brandon, again, thank you so much. We really appreciate you joining us, and we hope everybody has a great day. Thank you.